Welcome. Today, we're exploring how graph theory, a branch of mathematics, is revolutionizing the study of humanitarian terminology. Instead of just counting words, researchers now use networks, also called graphs, to reveal the hidden relationships between terms in scientific texts. This approach helps us see not only which words are most frequent, but also how they connect and interact, offering a richer understanding of an author's style and conceptual system. Let's embark on this journey to see how these networks are built and what they reveal about the minds behind influential scientific works. At its core, a graph consists of nodes. Think of them as points or circles, and edges, which are the lines connecting these nodes. In the context of language, each node represents a term, and an edge shows a relationship, such as two words appearing close together in a text. This visual structure allows us to map out complex systems of meaning, making it easier to spot central concepts and patterns that traditional methods might miss. By visualizing language as a network, we gain new insights into how ideas are structured and communicated. To build a network from scientific texts, researchers first process the text to remove common words and pronouns, focusing on meaningful terms. Then, they connect words that frequently appear near each other, within 5 words, for example. If two terms co-occur often enough, an edge is drawn between them. This method, inspired by the bag of words approach in computational linguistics, helps capture the context and relationships between terms, rather than just their individual frequencies. The result is a detailed map of the author's terminological system. Let's look at the network built from O.M. Freudenberg's scientific texts. Her network reveals a unique structure, with the term image standing out as the most central concept. Other important terms include death, form, tragedy, and God. Interestingly, Freudenberg's network resists centralization, meaning no single term dominates the system. This reflects her distinctive style, which values diversity and complexity in expressing ideas. The network visually highlights how her approach differs from more traditional academic writing. Next, we examine A.F. Losev's network. Here, the structure is denser, with philosophical terms like thing, number, and meaning taking center stage. The central part of Losev's network is more saturated, indicating a strong focus on core philosophical concepts. The higher centrality values for key terms suggest that Losev's writing is more thematically concentrated, with certain ideas tightly interwoven throughout his work. This network not only maps out his terminology, but also reflects the depth and cohesion of his philosophical system. Now let's turn to E.M. Meletinskiy. His network visually resembles Losev, with a strong central core. The most central terms are fairy tale, hero, and novella, reflecting his focus on narrative and myth. The high centrality values indicate a more homogeneous thematic field, suggesting that Meletinskiy's academic style gravitates towards a consistent set of core concepts. This approach is typical of classical academic writing, where clarity and thematic unity are highly valued. Key metric in these networks is degree centrality, which measures how many direct connections a node has. In other words, it shows which terms are most interconnected within the author's system. High centrality means a term is pivotal, linking many other concepts. By comparing centrality values across authors, we can see differences in their approaches. Some favor a tightly knit core, while others, like Freudenberg, prefer a more decentralized, flexible structure. This metric helps us quantify and visualize the unique style of each thinker. When we compare the networks of Freudenberg, Losev, and Meletinskiy, clear differences emerge. Freudenberg's network is decentralized and diverse, reflecting her unconventional style and resistance to academic norms. Losev and Meletinskiy, on the other hand, show more centralized and cohesive networks, typical of classical academic writing. These patterns suggest that an author's style and intellectual approach significantly shape the structure of their terminological system. Network analysis thus becomes a powerful tool for understanding not just what authors say, but how they think. In summary, using graph theory to analyze humanitarian terminology opens up new ways to visualize and understand scientific style. Networks reveal not just the key terms, but also the unique structure and logic behind each author's work. Whether highlighting diversity, cohesion, or thematic focus, these models offer a deeper look into the intellectual world of scientific writers. As network analysis continues to evolve, it promises to uncover even more about the hidden patterns in language and thought. Thank you for joining us on this exploration of networks in the humanities.